in a lot of ways, integration can be a lot more difficult than finding derivatives. So we're going to start off just by guessing and checking. First of all, let's take some things that we already know and try to apply them to some more complicated integrals. For instance, we already know about using a power in an integral, that to integrate x to the nth, we would raise the power by 1 and then take the coefficient divided by that n plus 1. As with any indefinite integral, we have to finish it off with a plus c. So when we're talking about 15x to the 4th, we want to raise the power to the 5th and take that 15 and divide by 5 plus c. So we'll end up with an integral of 3x to the 5th plus c. We already know that the integral of e to the x is e to the x plus c. So when we're multiplying e to the x by a coefficient like 3, the integral of 3e to the x should be 3e to the x plus c. Now we can check that to be certain by taking the derivative of 3e to the x and plus c. And the derivative of 3e to the x is 3e to the x. The derivative of the constant is 0. And we see that what our derivative was is the integrand here. So we were correct. When we look at the next example of the integral of e to 3x, so that 3 moves from being a coefficient of e to the x to just being a coefficient of the x. Since we're dealing with e, we would imagine that our integral is going to stay the same, e to the 3x plus c. Of course, what we should do is check it. So we're going to take the derivative of e to the 3x plus c. And when we get to that e to the 3x, we're going to have to use a chain rule because we have that 3x inside of e to the x. So the derivative of e is going to be e to the 3x. And then the derivative of 3x is 3. The integral, or the derivative of the constant, of course, is 0. So we see that our derivative is going to be 3e to the 3x, which is not the same as our integrand. Our integrand was just e to the 3x, and we got 3 times e to the 3x. So what we should do is go back and adjust our guess. Our result was 3 times bigger than we thought it should be, and so what I'm going to do is attach this coefficient of 1/3 to my e to the x. Now let's check this guess. If we're going to find the derivative of 1/3 e to the 3x plus c, we'd go 1/3. And then we use a chain rule on the e to the 3x to get e to the 3x times 3. And then our derivative of a constant is 0. So the 1/3 of 3 is going to cancel and leave us with e to the 3x, which is what we needed. Now we can use this knowledge that we just found and apply it to other situations like the integral of e to the 5x. That would mean that our integral is going to be e to the 5x, but we're going to need a coefficient of 1/5. We can of course check to make sure that there wasn't something special just about 3's by taking the derivative of 1/5 e to the 5x plus c and coefficient times the derivative of e to the 5x would be e to the 5x, chain rule, so we got to multiply by 5, and plus 0. The 1/5 of 5 cancels, and we are left with e to the 5x, which is the same as our integrand. Let's run through a few more standard integrals that we know about. For instance, the integral of 1 over x dx. We know that that's the natural log of x plus c. So when we have 4 over x, the integral of 4 over the x, look at that as being 4 times 1 over x dx. Because when we have a coefficient, we can just take the coefficient times the integral of 1 over x, so 4 times natural log of x plus c. You can check that to be certain by taking the derivative of 4 natural log of x plus c, and we'll get 4 times 1 over x plus 0, which of course is that 4 over x that we saw. When we have 1 over 4x, don't be fooled into thinking that 4x is inside, which, I mean, you could look at it that way, but it's a lot easier to view 1 over 4x as 1/4 times 1 over x dx. Then we have that coefficient of 1/4 times the integral of 1 over x, which would be the natural log of x, plus c. We know that the integral of cosine is sine, so we'll have sine of x plus c. So when we have a negative cosine, just of course treat that like there's a -1 in front of there. And since that is a coefficient, we could take the coefficient times the integral of cosine. So the integral of cosine is sine plus c. When we have that coefficient inside of the function, we have to see how that's going to affect it. The integral of cosine, of course, is sine. So maybe our guess is sine of -3x plus c. And we check it by taking the derivative of that sine of -3x. I know that the derivative of that constant part is going to be 0, so this is the only part I really care about. And when we take the derivative of this sine of -3x, we have to use chain rule. Derivative of sine is cosine, but then the derivative of -3x is -3. So we have to go back and adjust our guess to get rid of this -3, so I'm just going to add the coefficient of 1 over -3, and that'll work. And let's finish it off with the integral of negative sine. We know the integral of negative sine is cosine. So when we have the integral of just sine, that should be the opposite of cosine. And of course, we should probably check that by taking the derivative of negative cosine. That's like -1 times cosine, so -1 times the derivative of cosine is negative sine, which would leave us with a positive sine of x, which is what we wanted. So when we're trying to find the integral of sine of 7x, just kind of deal with each piece. The integral of sine should be negative cosine of that 7x. And I think that in order to deal with that 7x as a chain rule, I'm going to have to take all of this and multiply it by 1/7. We can check it real quick by taking the derivative of -1/7 cosine of 7x, and we would have -1/7 times the derivative of cosine is negative sine of 7x times the derivative of 7x, which is 7. The 7 and the 1/7 cancel, and two negatives make a positive, and all we're left with here is the sine of 7x, which is what we wanted. So I'm going to go back and rewrite my answer so it looks nice. I've got -1/7 cosine of 7x, and I'm not going to forget my plus c. And there we go.